So in this video, I want to apply the fundamental theorem of calculus to try to find the average value of a function. Now, the function I have here is f of x equals negative x squared plus 2x plus 3. I went ahead and graphed it. Notice it goes to the points 0, 3, 1, 4 is its vertex. It also goes through 2, 3, and 3, 0. Now, my goal is to find the average value over that interval 0 to 3, which, like I said, I graphed. So, here's what we're going to do. I'm going to kind of throw back to when you were in middle school or even in high school when you first learned how to calculate the average value of something. So what you would have done when you were trying to find the average value, you would have taken all of your data points and you would have added them up and divided by how many data points there were, which is a great strategy to do when you can count how many data points there are. Here's the problem. On this interval from 0 to 3, there's an infinite number of values. There's no way I can add every single one of them up and then divide by how many there are. Or is there? And that's where the fundamental theorem of calculus comes in. Instead of trying to approach this, which would work for something discrete, I'm going to approach it from something that's going to handle something that's continuous. So what we're going to do is we're going to do a definite integral. Okay? So we're going to do our definite integral from a to b, or in this case from 0 to 3, of our function. And after we do that, we're still going to divide by something. We're just going to divide by how big the interval is. So in this case, 3 minus 0, which is just 3. So I'm going to go ahead and start working on this problem a little bit. So here I go. Again, the definite integral from 0 to 3 of my function, which is negative x squared plus 2x plus 3 dx. And then I'm going to divide by 3 minus 0. So I'm going to go ahead and finish working out this problem. 3 minus 0 is 3. And I'm going to go ahead and start doing the definite integral here. Now, hopefully you guys worked in the last lesson on improving your skills on this. So what I'm going to do is I'm just going to kind of focus on doing the integral. So it's going from 0 to 3. That's where I'm evaluating it from. And so with this negative x squared, it's got a negative 1. And remember, we're going to kick that exponent up 1, and we're going to divide by the new exponent. So it's going to be negative 1 over 3 x cubed. Again, kick the exponent up 1 and divide by the new exponent. So it's going to be 2 divided by 2x squared. That'll simplify before I do anything else. And that's 3x to the 0, so that's going to become 3x, okay? So, like I said, I'm going to go ahead and simplify. 2 divided by 2 is just 1, so I don't even need to write it anymore. All right, now I'm ready to just go ahead and figure stuff out. Now, I'm going to save the 1/3 for the very end, and I'm going to go ahead and evaluate this from 0 to 3. So, that's going to be negative 1/3 times 3 cubed plus 3 squared plus 3 times 3. And then we're going to subtract all of that stuff when we plug in 0. So negative 1/3 times 0 cubed plus 0 squared plus 3 times 0. And that should finish it off. Now, hopefully you guys are starting to figure out that, especially if you're evaluating it at 0 for a definite integral, all of this stuff is just going to kind of disappear. It's just going to go to 0. So really and truly, I'm just going to work on the rest of this stuff. So I've got negative 1/3 of 3 cubed plus 3 squared plus 3 times 3. So essentially that's going to become negative 1/3 times 3 cubed. 3 cubed is 27, but then you're going to take out a 3. So you're going to get negative 9. And then it's going to be 3 squared, which is 9, and then it's 3 times 3, which is 9. So those are going to cancel. So you're going to end up with 1/3 of 9, which is just 3. And so the average value of this function up here is actually 3.